There are also three types of triangles relating to the angles that a triangle contains. So we've looked at the three types of triangles relating to the length of the sides of the triangles, but now we're going to be looking at the angles inside of a triangle, so the three angles of a triangle. If you have learned about angles already, you can use your knowledge of angles to create and look at these three types of triangles. If you have not learned about angles yet, be sure and watch the angle video before proceeding. First, we have the right triangle. A right triangle is a triangle that has one right angle, which is a 90-degree angle. The other two angles of a right triangle will always add up to 90 degrees, and we'll take a closer look at this soon, but remember that all three angles of a triangle will always add up to 180 degrees. So in a right triangle, we have one angle that is exactly the measurement of 90 degrees, and the other two angles will add up to and equal 90, since 90 plus 90 equals 180. The second kind of triangle that we have in this category relating to the angles is called an acute triangle. And in an acute triangle, it is a triangle where all three angles inside of the triangle are less than 90 degrees in their angle measurement. So this is an example of an acute triangle because the angle measurements are 80 degrees, 40 degrees, and 60 degrees. And so all three of those angles are less than 90, making this what we call an acute angle triangle. The third type in relation to the angles is called an obtuse angle triangle. And an obtuse angle contains one angle greater than 90 degrees. So in this case, I have 120 degrees in one of my angles, 40 degrees and 20 degrees in the other two. And so since this triangle contains one angle whose measurement is greater than 90, that makes this an obtuse angle triangle. So it's a very important rule to understand and to remember is that the sum of all the angles inside of a triangle will always add up to 180 degrees. It does not matter what kind of triangle you're looking at. It could be an equilateral triangle, an isosceles triangle, a scalene triangle, a right angle, acute angle, obtuse angle triangle, these that we've just looked at. In all cases, the sum of the interior angles of the triangle will always add up to 180 degrees. We've got three examples here. In this triangle, we have three equal angles of 60 degrees each. 60 degrees, 60 degrees, and 60 degrees. 60 plus 60 plus 60 equals 180. In this right triangle example, we have a right triangle, which remember is marked by a little square in the corner, and that tells us that that's 90 degrees. So we have a 90-degree angle, 60 and 30. 90 plus 60 plus 30 equals 180. And then in this obtuse triangle, where we have a 105-degree angle here, we have 50 degrees here and 25 degrees here. And so 105 plus 50 plus 25 equals 180 degrees. The three interior angles of a triangle always add up to 180 degrees. Let's look at a couple of examples of triangles. In this first question, we are asked, what kind of triangle is this? Well, first of all, we can look at the sides. And we can see in this triangle that we've been given the measurements of two of the sides as being 3 units each. which means that two of the sides of this triangle are the same length, meaning that it is an isosceles triangle. We can also see when we look at the angles inside of this triangle that one of the angles has a little square there, indicating that it is a 90-degree triangle, a 90-degree angle, right angle triangle. And so we can combine these two terms of isosceles having to do with the sides and right angle triangle having to do with the angles. And we can call this then an isosceles right triangle. We'll give it a title there, all capitalized, isosceles right triangle. Although if you are writing an isosceles right triangle in an example or for an answer or in a sentence for some reason, you don't have to capitalize all of those. This is an isosceles right triangle, is the name of this kind of triangle. In our second example, it asks us the question, is an equilateral triangle also an acute, obtuse, or right triangle? So let's take a look at an equilateral triangle. I have a little one drawn here. All three sides are the measurement of 2 units. And so we know that it's equilateral. All three sides are the same length. And in an equilateral triangle, our 3 angles, the 3 interior angles inside of an equilateral triangle, are always 60 degrees each. So we have 60 degrees, and 60 for our 3 angles inside of the triangle. Now, if you remember the definition of acute, obtuse, or right triangles, all having to do with the interior angles of the triangle, and when all 3 of the angles inside of a triangle are less than 90 degrees in measurement, we call this an acute triangle. So an equilateral triangle is also an acute triangle. So we can say here for our answer that equilateral triangles are also acute triangles. I could probably have come over here and put a big square around the word acute and had that as my answer. Equilateral triangles are also acute triangles. In our third example here, it's asking us, can an isosceles triangle, so 2 sides being the same length, can an isosceles triangle be an acute triangle also? And the answer to that question is yes. Let's take a look at this triangle I have drawn here. I can see that I have 2 sides given as 3 units of measure, which means they're the same length as each other, meaning that it's an isosceles triangle. 2 equal lengths makes it an isosceles triangle. And then when I look at the angle measurements of this particular triangle, I can see that I have a 30-degree angle up here for my smaller angle, but then these 2 angles here are both 75 degrees. And so, since the definition of an acute triangle is a triangle in which all 3 angles are less than 90 degrees, then yes, this isosceles triangle fits the definition also of an acute triangle, with all 3 angle measurements less than 90 degrees and 2 sides of equal measure. Our last example, dealing with triangles, asks us to find the missing angle. So we have a triangle with 3 interior angles, 3 angles. 2 of them are given, and the third one we need to find. So our first given angle is 100 degrees. Our second given angle is a 30-degree angle, and we need to find the measurement of this last third missing angle here. So we can see that we have 100 plus 30 equals 130 degrees of these two angles. And we know that all three angles need to add up to 180 degrees. So in order to find our third angle, we take 180 and we subtract 130 to find the missing angle of 50 degrees. So this angle here is going to be a 50-degree angle. We want to check our work real quickly by adding up the angle measurements of the three angles of our triangle and making sure that they add up to 180. So 100 plus 50 equals 150 plus 30 equals 180.